Welcome back everybody. This is our 7th class in JEE mains previous year questions for chapter current electricity of class 12th. Before this, in this series we have made 6 videos and all of those videos are available on our YouTube channel in playlist section. We have also started similar previous year series for NEET aspirants also. So you can go to our playlist section, channels playlist section, and can find those playlists. And if you find these videos useful, then do press the like button, share them as much as possible, and subscribe to our channel. Also, if possible, then do make some donations by scanning QR codes in front of your screen. By your donations, even however small they are, they motivate us to keep on making these videos on regular basis. With this, let's start today's video and start doing the questions. Now I think we have reached up to 50. Yes, this is the last question, 56. We have reached up to question number 56, and today we will go further with 57. So as shown in the circuit, potential difference between A and B that we have to find out, and we can see that here we have 3 batteries. This is battery number 1, battery number 2, battery number 3, all of these are in parallel. All of these three batteries are connected in parallel, and we have a voltage, two resistances here of 10 ohm and 5 ohm. So what we can do, we can simply find out their what will be their equivalent parallel combination, and then we will solve further like we have done in the previous question, I think. Not in previous. Yes, this was the question number 54. You can see it in our previous video, that how we have solved it. So we will be using same method here in our current question. So let me redraw the diagrams with slight modifications. So we have a 5 ohm resistance here. We have a 1 ohm resistance and a battery connected here. We have a 1 ohm resistance and a battery of 2 volts connected here. This is 1 volt battery, 2 volt battery. And again we have a 1 ohm resistance and 3 volt battery. And we have a 10 ohm resistance. Now what we can do, we can consider this as a single system. We can consider it a 1 volt battery with internal resistance of 1 ohm. Now we can consider the middle one as a 2 volt battery with internal resistance of 1 ohm, and the bottommost one as a 3 volt battery with resistance of 1 ohm. So if we do this, then we can find out their equivalent potential or equivalent battery. That can be done via using formula this, that EMF will be given by combined EMF will be summation I EI by RI by summation I 1 by Ri, where I is the number of total terms we have or batteries we have. Here we have 3 batteries and their respective 3 resistances. So EMF will be 1 by 1 plus 2 by 1 plus 3 by 1 divided by 1 by 1 plus 1 by 1 plus 1 by 1. So this will give us 6 by 1, or so combined EMF will be 6 volts, and combined resistance will be, because all of these 3 resistance are in parallel, so combined resistance will be 1 by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3, as all of these are 1, so 1 by 1, 1 by 1, 1 by 1. So this comes out to be 3 by 1. and combined resistance comes out to be 1 by 3. And oh, we made a mistake here, it will be 3. So potential will be 2 volt. So now our this circuit can be represented something like this, that we have a 5 ohm resistance, then we have a 1 by 3 ohm resistance with a battery of potential 2 volt, and then we have a 10 ohm resistance. These are our point A and point B. Now as we can see, A and B are not connected. This is not a closed loop, and no current is also given here. So as no outside current is given and there is no closed loop, so from this circuit there will be no current is flowing. And if there is no current is flowing, then potential across point A and B will be equal to potential across the battery, and potential across the battery is 2 volts. So answer for this question will be 2 volts. Now next move to next question. In the given circuit, cells have zero internal resistance. The current passing through the resistance R1 and R2 respectively. So we have to find out the currents. So that can be done easily. We can use superposition principle here. Let's suppose let's mark some points A, B, C, D, E, F. Now here we have 3 closed loops. First is A, B, E, F, A. Second is B, C, D, E, B. And third is A, B, C, D, E, F. So that's how we can make 3 closed loops here. So consider in the first loop, current is flowing from positive terminal of the battery to negative terminal. So like this, and it will be anti-clockwise. And value of current is suppose I1. In the second, we can say second loop, consider current is flowing from positive to negative. So it is flowing something like this, and it's over here, this will be something like this. Here value of current is I1, and here value of current is I2. So we will first solve for the first loop, then for the second, then we will form some kind of relation, and then we will solve them. And we will find a value of I1 and I2. So for loop A, B, E, F, A. Now as current is flowing from positive to negative, so here R1 will be, as current is entering from the below, so bottom point will be positive and top point will be negative. And here in R1 we have I1 plus I2 also, because both of the current for R1 are entering from the below. I1 is entering from the below and I2 is also entering from the below and leaving from the top. So for R1 both of the currents are in same direction. So let's start from the point A. As we start from the point A, what we encounter? First we encounter a battery from negative to positive, so we will take it positive. Then from point B going to resistance R1, we encounter positive to negative, so we will take negative. Value of R1 is 20, and there are 2 currents flowing in through it, that is I1 and I2. So I1 plus I2, and then there is a no, we can say there is no further element involved in the circuit, so we will come back to again A. So it will be 0, because we started from the point A and we came back to point A. So difference from A to A will be 0. So what we have written should be equal to 0. Now let's write for the second loop. Loop B, C, D, E, B. B, C, D, E, B. Now starting from the point B, first we encounter a battery with positive to negative, so it will be negative 10. Then we encounter a resistance of 20 ohm, and in this loop direction of current is something like this. It is clockwise. So if this is clockwise, this will be positive, this will be negative, as current will be coming downward here and going upward in the case of R1. So this will be positive, this will be negative. So minus 10 minus plus means plus 20 times I2 and minus plus 20 times, in this resistance we have two currents, I1 and I2. So I1 plus I2 is equal to 0. Now we know if we slightly adjust this equation, then from this we can write that 10 is equal to 20 I1 plus I2. So 20 I1 plus I2 is equal to 10. So minus 10 plus 20 I2 plus 10 is equal to 0. 10 get cancelled, and from this I2 is equal to 0. And if I2 is equal to 0, then 20 I1 is equal to 10 and I1 is equal to half or 0.5. So option C will be the right answer. Moving to next question. So in this circuit we have given we have a switch S. When it is closed, then the value of current I will be. So when this switch S is closed, so we have to find the value of this current I, and we have given at point A there is potential of 20 volts. Current I1 is flowing here through 2 ohm resistance, and at point B we have a 10 volt potential, and current I2 is flowing through 4 ohm resistance. Now first of all, let's apply junction law here, and this will adjust slightly. So we can say at point C, sorry, not point, we got habitual to writing points. At junction C, incoming current should be equal to outgoing current. So incoming currents at junction C is I1 from the A side and I2 from the B side. So these are the incoming currents, and outgoing current is I. So we can say I1 plus I2 is equal to I. This is our first relation. Now let's write potential for potential equation here for point C, from A to C, then from B to C, and then C to ground, or VG, which is equal to 0. So first for point A to C. So as we know that current is flowing from A to C, so for this resistance, this will be the positive terminal and this will be the negative terminal. This will be positive one and this will be negative one. So we can say VA minus, because after plus we encounter minus, so we only take second one, minus twice of I1 is equal to VC. Similarly, if we write for B, and we know value of VA is 20, so 20 minus 2I1 is equal to VC. And if we take for the point B, VB, and current is flowing in this direction, so this will be this point will be positive and this point will be negative. So positive, negative, again negative, so minus 4I2 VB minus 4I2 is equal to VC, or VB is 10 minus 4I2 is equal to VC. So that's how we got two equation for VC. So both of these should be equal, and we can say 20 minus 2I1 is equal to 10 minus 4I2, and from this we can say 10 is equal to This will go here and positive, so 2i1 minus 4i2, and from this 5 is equal to i1 minus 2i2. So this is our first equation between i1 and i2. Now let's come to point C. As we know that we consider that there will be some potential at point C, and here from the point C current is going downward, so this will be positive, this will act as negative. And if we write equation between point C and ground, so Vc minus positive negative negative 2I current or resistance into current is equal to 0. So Vc is equal to twice of I, and value of I is equal to, we already have value of I, that I is equal to I1 plus I2. So Vc is equal to twice of I1 plus I2. Now let's use this equation on our first. So that is, this is our first equation, this is our second equation, and this is our third equation. Now use 1 and 3, compare 1 and 3. So 20 minus 2i1 is equal to Vc is equal to 2i1 plus 2i2. And from this what we get, divide whole equation by 2. So 10 minus i1 is equal to i1 plus i2, and from this we get 10 is equal to, this will get and added here, so twice of i1 plus i2. So 10 is equal to twice of i1 plus i2, and we have another equation here. We have this one and we have this one. Let's use both of these equations. So first one is 10 is equal to 2i1 minus 4i2. Why we are using this equation instead of this? Because we have to cancel i1 or i2, either i1 or i2, and in this scenario we have 2i1 and here we have only 1 i1, so we will be using equation with 2i1 so that our mathematics can be little bit easier. And 10 is equal to 2i1 plus i2. Now we can subtract both of these equations, so minus minus minus, and from this 10 minus 10 is 0, i1 get cancelled, 0 minus 5 i2, and from this we can say that i2 is equal to 0, and if i2 is equal to 0, from the our initial setup, if i2 is equal to 0, we can put i2 here. If i2 is equal to 0, then twice of i1 is equal to 10, and i1 becomes 5 ampere, and then I also becomes, because I is equal to I1 plus I2, so I becomes 5 ampere, and this is the value we have to find. We had to find value of I, so I is equal to 5 ampere. Moving to next question. Two batteries of EMF 12 volt and 13 volt are connected in parallel across a load resistance of 10 ohm. Internal resistance of the two battery is 1 ohm, 2 ohm respectively. Voltage across the load lies between. So we have to find out voltage across the load. So let's first draw the diagram that we have two batteries. With internal resistances. So suppose this is our first battery with internal resistance of 1 ohm, and we can draw internal resistance anywhere in the front of the battery or in the backward. Normally it is drawn in the backward side, but you are free to choose any of the side, with 12 volt potential. And we have another battery of 13 volt with 2 ohm resistance. They are connected in parallel across a load of 10 ohm. So here load will be something like this. So we can say that load is also in parallel. Now we have to find out the voltage difference or potential across here, potential difference across the load. Now we can see from the figure that both of these batteries are in parallel with their sum of their internal resistance. So what we can do in this question, we can replace both of these batteries as they are in parallel by their single equivalent battery with their single equivalent internal resistance. So, and we already know that how to find equivalent resistance. So equivalent EMF will be given by summation I EI by summation I 1 by Ri. That will be the equivalent EMF. So this will be 12 by 1 plus 13 by 2 divided by 1 by 1 plus 1 by 2. So combined EMF will be 12 plus 13 by 2. This is 24 into 13 or 24 plus 13. So that will give us 37 by 2. And on the denominator, in the denominator we will get 3 by 2. So it will get cancelled. So combined EMF is 37 by 3 volt, and combined resistance 1 by R will be combined resistance of both of these batteries, as both of resistance are in parallel. So 1 by 1 plus 1 by 2, that is 3 by 2. So R will be 2 by 3 ohms. So this circuit can be represented in equivalent basis with a battery of 37 by 3 volt with internal resistance of 2 by 3 ohm, and they are connected in series with this 10 ohm resistance. Now to find voltage across this 10 ohm resistance, what we have to do? First we have to find out the current in the circuit, and then we will multiply it by 10. V is equal to I. So I will be current in the circuit, total potential 37 by 3 divided by total resistance, so 10 plus 2 by 3. So this will be 30 plus 32 by 3, so 37 by 32 ampere. This will be the current in the circuit, and potential drop across or potential appearing across this 10 ohm resistance will be 37 by 32 into 10, and that comes out to be 11.56 volts. That lies well within option B's range, 11.5 to 11.6. Moving to next question. In the circuit, the current in the 1 ohm resistance will be, so we have to find current through this resistance. So let's slightly adjust and start. Now suppose as we have first name here, let's make some naming scheme. A, B, C, D. Okay, sorry, this is not B, this is actually Q. Let me use slightly darker color. So A, this is Q, this is B, yes, C, and D. So now we have two loops here. First loop is, or we can say actually three loops, A, Q, P, D, A. This is our first loop. Second loop is Q, B, C, P, Q, and third loop is A, Q, B, C, P, D, A. This is our third loop. Normally, we only use two loops, and from these two loops, we will get enough equations to solve our question. So let's start. Now, suppose in our first loop, in this AQPD, current is flowing something like this. So anti-clockwise. And in our second loop, current is flowing again anti-clockwise. These are random directions, and you can choose any one direction, whatever you want. You can be anti-clockwise in both, one in clock and one in anti-clock, and clockwise in both. Whatever you choose, it up to you, and we have to just solve equation accordingly. And there will be no changes in the answer. Answer will be the same in all of the conditions. So let's start with first loop. Loop A, Q, B, D, A. This is the loop we are considering here. So in this loop, current is flowing anti-clockwise. So this point will be positive for this resistance as current is entering from this side, and negative for this resistance. Again, positive here and negative here, and we have battery here. And for this resistance of 1 ohm between P and Q, if we can see, this current is I1 and this current is I2. So we can see I1 is going from bottom to top. I1 is going from Q to P, and I2 is going from P to Q. So while we are considering loop AQPDA, this loop we will consider that I1 is greater. We will assume that I1 is greater. For second loop, when we do calculation for the second loop, we will assume that I2 is greater. Okay. So in this loop, we will be considering that I1 is greater. So net current in this 1 ohm resistance connected between P and Q will be flowing from bottom to top. So if net current is flowing from Q to P, so this point will be positive and this point will be negative. So let's start from the point A. When we start from the point A, first we encounter 3 ohm resistance, positive to negative. So we will consider negative. So minus 3 I1. Then at point Q, and we encounter a 1 ohm resistance with positive to negative. So again negative with 1 times current flowing through it, that is I1 minus I2, net current flowing through it, I1 minus I2. And then we encounter a battery, that is negative and positive, so positive 6 is equal to 0. So this is our first equation. Now let's solve it further. So minus 3 I1 minus I1 plus I2 plus 6 is equal to 0, or minus 4 I1 plus I2 is equal to minus 6. This is our first equation. Now going to second loop. Loop QBCPQ. QBCPQ. Starting from point Q, as current is flowing again anti-clock in this loop, so this will be, current will be entering from here, 3 ohm resistance, and leaving from this side. So positive to negative, again negative, so minus 3, and in this 3 ohm resistance we have I2 current, so minus 3 I2. Then we encounter a battery, negative 2 positive, so positive 9. Then we encounter a resistance of 2 ohm, that is again current is flowing like this, so this terminal will be positive and this terminal will be negative. So positive to negative, negative, so minus 2 I2. And now for this loop, we consider that I2 is greater, and if I2 is greater, so current will be entering from here in I2 and leaving from the here, so positive to negative, so minus 1. And I2, as I2 is greater and I1 has direction opposite to I2, for 1 ohm resistance, I2 is going downward and I1 is going upward. So, and in this loop, we consider that I2 is greater, so this will be I2 minus I1. is equal to 0. So solving it further, taking 9 to this side, this will be minus 9. So minus 3i2, sorry, not minus, into minus 2i2 minus i2 plus i1 is equal to minus 9, and this comes minus 6i2 plus i1 is equal to minus 9, and we can write it like i1 minus 6i2 is equal to minus 9. Now we have to here we have positive, here we have negative, so let's make it positive. So this will be 4i1 minus i2 is equal to 6, and multiply this whole equation by 4. So this will be 4i1 minus 24 of i2 is equal to minus 36. We multiplied this whole equation by 4 so that we can do addition subtraction easily, or our mathematics comes easy. So subtracting, minus, plus, plus. So this 4i get cancelled, and we have 24i2 minus i2. So 23i2 is equal to 36 plus 6, 42. So i2 is equal to 42 by 23. Now solving this, we get i2 is equal to 1.86 ampere, and when i2 is 1.86, we can use it here to find value of i1. So i1 minus 6 multiply 1.86 is equal to minus 9, and 1 point, sorry, not 1.86, 1.83, 1.83. It was 1.826. So 1.83 multiply 6. So I1 minus 10.96 is equal to minus 9, and I1 comes out to be minus 9 plus 10.96, and what we get, I1 is equal to 1.95 ampere. So we have value of I1 and I2. Let's go on the question. So I1 is 1.95 and I2 comes out to be 1.83, I think. Yes, 1.83. Now let's see the directions. For as we have to find direction for the current in PQ. So for PQ, I1 is going up, I1 is going up, and I2 is going down. I2 is going down, and we know value of I1 is greater than I2 by amount 0.12 ampere. So current in this 1 ohm resistor should be going upward from Q to P with amount 0.12, and option A, that is 0.13, because there can be, we can say, rounding off from Q to P is the right answer. Value of current that will be either 0.13 or 0.12 depending upon how much rounding you do. So with this, let's move to next question. So in an electric network shown when no current flows through the 4 ohm resistance. So this is 4 ohm resistance. In the arm EB, potential difference across point A and D will be. So we have to find out potential difference between A and D. Now as mentioned that there is no current flowing in there is no current flowing between A and D. Oh, sorry, not E. There is no current flowing through arm EB. So if no current is flowing through this arm, means potential at point E should be equal to potential at point, what we can say, B. So potential at B is equal to potential at E, and we know from this that potential difference between A and B is provided by this battery. And supposing this battery is something like this, that this is the positive side and this is the negative side, then we can say that VA minus VB is equal to 9. Okay, because between point A and point B a battery is connected, so potential difference between both of these points should be equal to 9, and E and D are connected with the help of a straight wire, so they should be at equal potential. So VE is equal to VD. So now using this and this, we can write that VB is equal to VE and VE is equal to VD. So VB is equal to VD, and from this one value of VB will be VA minus 9. From this, VA minus 9 is equal to VB. So VA minus 9 is equal to VB, and that is equal to VD. And so VA minus VD should be equal to 9, and none of the option matches here, so all options are wrong. Actual answer will be 9 volts. Now let's move to next question. Circuit shown here has a two batteries of 8 volts and 16 volt and 3 resistor. So this is 16 volt battery, this is 8 volt battery, 3 resistor, 3 ohm, 9 ohm and 9 ohm, and a capacitor of 5 microfarad. Here is the capacitor. How much current I in the circuit in steady state? So we have to find current in steady state. Now as it is steady state, capacitor in steady state, so in steady state capacitor charges to full of its capacity and there is no further current flowing through it. So if there is no further current flowing through it, so this whole part is removed from the circuit. This capacitor and the resistance attached to it is not functioning in the circuit. So our effective circuit will be something like this. We have here 3 ohm resistor, we have a battery here of 8 volt, then we have a 9 ohm resistance, battery of 16 volt, and they are connected in such a way. So suppose, as already given, that current I is flowing in the circuit. So this is the current I and it will be flowing everywhere. So let's start. This is point A, B, C, D. So as direction of current is this, so our for this will be positive. For this resistance, this will be positive terminal, this will be negative. For battery, this is positive, negative, and 8 volt battery. And for this resistance, this is term positive point and this is negative point. Starting from point A, first we get a battery with negative to positive, because for battery negative positive stay the same, negative to positive, so positive 16, then resistance positive to negative, so minus 9I, then again resistance positive to negative, so minus 3I, then a battery positive to negative means minus 8, then we again back to point A, so equal to 0. So 16 minus 8 is 8 is equal to 12I, and I is equal to 8 by 12 or 2 by 3, that is 0.67 ampere. Option B will be the right answer. So with this we end this video here. Hopefully whatever we have covered will be helpful to you and will make your understanding somewhat better. And again, if you like this video, do press the like button, share it as much as possible, and subscribe to our channel. If you have any doubts, suggestions, you can put them in comment section. I will try to implement them or clear them. And also, if possible, do make some donation by scanning these QR codes. Even a small donation help us to keep this series ongoing on regular basis. So with this again, thanks for watching, and we will meet in next video.